Hello, this is a rundown of tectonic boundaries and what landforms they form. If you are listening to this, it means that I am dead. But more realistically, it's probably because you sucked at something and now I've made you do this again. And I hope I'm speaking to Year 9 because if you're in Year 11 and you're doing this again, you're doing something wrong. Here's the rundown of today. We're going to go through the three types of tectonic boundaries: convergent, divergent, and transform. And this is the big one here. You need to be able to tell me what type of tectonic disaster happens at each one and what sort of movement happens at each one. So to be successful for you today, you're going to have to finish this, watch this up, and write down in your books a table so you can tabulate each boundary, the movement of each boundary, and the tectonic disasters, the landforms that happened at each one. So what we're talking about there is where the volcanoes and earthquakes form at each particular type of boundary. Okay, so the first one is called convergent. This comes from the word converge. And the meaning of the word to converge means to come together or to join. So when we talk about a convergent boundary, what we're talking about is two tectonic plates actually moving together, like so. Now these two plate boundaries are very thick, so these would be continental. When continental plates come together, you end up squishing into each other and they form these folding mountains that go like this. But we're not going to worry about that for the moment. What we want to worry about is the other type of convergent boundary. And this is the more important one. What happens when you have a very thick piece of continental crust and a very thin piece of oceanic crust, and they're moving towards each other? Now the oceanic crust is very thin because it's got ocean on top. So converging means these two come together, and I'm going to steal, shamelessly, an animation that Unite made for me. Courtesy of Mr. Fruin, plagiarized shamelessly here, we've got a diagram of the ocean, the oceanic crust, and below that magma is in the mantle. And when I press play here, hopefully I can press play. Yep, there it goes. We've got the oceanic crust coming together. Happens very quickly there, let's go again. Oceanic crust is thinner, so it slides underneath the continental crust, gets down into the mantle, and because the mantle is very hot, it melts down there. So you've got a whole lot of melting happening down here. This plate moves down, slips under, very hot down here, so it melts, hot things rise, and the magma comes out and it forms a volcano. Okay, take note. 1. There is a volcano. 2. There are earthquakes. Now the volcano speaks for itself. When the oceanic crust goes down, it melts, it forms a volcano. The earthquake comes from the fact that this oceanic plate slipping underneath is not a gentle process. A whole lot of pressure builds up there until suddenly it slips under and it moves under all at once. And that leaves you with a big shock wave that emanates, and you get an earthquake coming out on both sides. This is the diagram that we will have in our books. We want to be able to label this, so you probably do need to go back and have a look over that worksheet here. We've got a diagram of this as the oceanic crust. The movement goes down. The X's here represent the melting, and the magma goes up because hot things rise and we have a bit of an eruption there. Now these arrows down the bottom are the convection currents in the mantle. And you can see if the oceanic crust is floating on the convection currents and they are moving around in this cycle, that is what's pushing these two plates together. And that's a pretty good rundown of a convergent boundary. Must remember, 1, volcano, and 2, earthquakes do occur at a convergent boundary. Divergent boundary is the opposite. Diverge means to separate or to go apart from each other. So really easily here, if you have two plates and they're moving away from each other, the gap in the middle gets wider and wider, and I mean that's a pretty perfect opportunity for magma to come up over the top. So in a nutshell, yes, that's a volcano. It's not an eruption, no, not a spectacular eruption, but the lava does come up and it bubbles out and it moves in that diverging direction. And again, here we have an animation courtesy of Mr. Nori. Shows the convection currents coming up, an eruption, and it spreads out on both sides. So in case you missed that there, this is definitely a volcano. A volcano happens at a divergent boundary. Now this is probably more relevant for year 11, so year 9, this is a bit of an extension for you, but this sort of boundary is gentle. There is no volcanic pressure building up. This lava comes out really nice and slowly, and it just runs out like honey. So there's no earthquakes that happen at this one. So yes, volcano, no earthquakes. And here's your diagram we've drawn in again. It's got your convection currents going up, hitting the underside of the crust and cycling around. And in the middle of the gap here, the lava spills out, and that makes basalts, type of rock, and that spreads out in either direction, and that's the word divergent. This happens in the middle of the oceans, and this is why we call it a mid-ocean ridge. Some of the tallest mountains on Earth are part of the mid-ocean ridges, because these are very, very tall, essentially valleys, and the valley goes all the way down into the mantle. So oceanic crust and mantle down here. And that's that for divergent boundary. To sum that up, yes, volcano. No for earthquakes. The third type of boundary is called a transform boundary. For you guys in year 11, this is called a conservative boundary, more correctly. The reason why it's called a conservative boundary is because nothing is created or destroyed. As to why it's called a transform boundary, I think it's mostly because the fault line that forms is called a transform fault. I'll draw you a picture. So you've got a section of crust, it's probably land, just looks like this. But if there are pushing forces on this side pushing it one way, and on this side pushing it another way, that force really builds up until the rock can't take it anymore, and it'll crack down the middle, and that'll shift this side across to there, and it'll shift this side across to there, in usually one strong motion, because the forces build up and rock is not a very flexible thing, and when it snaps, it snaps. So this moves across in one big shake, and that moves across in the other big shake, and you do get a very large earthquake. Today's animation is courtesy of Miss White. She's shown the, really too quickly, but they are two plates that have then slipped sideways, and the fault line down the middle is called transform fault. Here's our diagram there. We've got one shifted this way. One shifted that way, the other one shifted that way. This little labelled line in here for the transform fault. As you can see, there is no volcano. This is no lava involved, and that means that number one sort of tectonic disaster that would happen at this sort of plate boundary is an earthquake. And pretty destructive earthquakes too. Okay, for you to do, what we needed to do today to get out of this was to run through convergent, divergent, and transform boundaries. You need to be able to tell me what is the movement at each boundary. So to converge means to come together. To diverge is to move apart. Transform is to move in opposite directions. And you need to make a table for me, please. Title, rule and a pencil. Each boundary down this side, convergent, divergent, transform. And in the next column, the movement. So convergent coming, divergent are moving away, transform side by side. And then another column to make sure that you know the characteristic tectonic disaster that happens at each. You'll need to watch this again probably. I would make up your table in your book, and I'm sure that I'll go through it with you at some point in the future or make you do an exam again. That's it. Thanks very much.